In this video, I'm going to work through some sample problems for mass percent, molarity, and then a couple of dilution problems. So the first problem in your PowerPoint slide reads like this. A solution is prepared by mixing 1 gram of ethanol with 100 grams of water. Calculate the mass percent of ethanol in this solution. So remember from our PowerPoint, this is our formula for mass percent. We need to take the mass of the solute, which is given in the problem, right? It tells us we have 1 gram of ethanol divided by the mass of the entire solution. Okay, the key thing here, you guys, remember solution is the solute and the solvent. Okay, a lot of times people only do the mass of the solvent and the denominator here. That's a no-no. The solution is the solute and the solvent together. Take that fraction, multiply it by 100 to convert that decimal to a percentage, and there's your answer. Okay, so here we would say our mass percent is equal to our mass percent of ethanol, which was 1 gram, divided by the total mass of our solute, which would be that 1 gram, and our solvent, 100 grams. So we have 101 grams total of solution times 100. Okay. And we end up with 0.990 percent ethanol. Okay, so if you have this solution, it's 0.99% ethanol by mass. Okay, and that makes sense. Remember, your solute is the smallest part of your solution, so this should definitely be not too huge of a percentage. Okay, we have another problem where we're going the opposite way. Okay, we are given the mass percent of lactose in this problem, and they want to know how much lactose is present in a given amount of solution. Okay, so now we're given that 4.5%, right? That's the mass percent of lactose is equal to the unknown mass of lactose in 175 grams of milk, and milk is our solution here. Okay, so to solve for this variable, we need to, first of all, divide both sides by 100%. So we end up with this. Okay, and then to solve for x, we need to multiply both sides by 175. So you need to take 0.045 times 175, and then we end up with 7. We want 2 sig figs here, 7.9 grams of lactose. Okay, so that's mass percent. It's super straightforward. Make sure if you have any questions that you're coming to the Zoom meetings and asking. Okay, then we move on to molarity. Okay, so these are the two problems on the molarity slide. These ones are really important that we understand. And again, hopefully they're pretty straightforward. Just sometimes molarity problems require, like a few more conversions, right? Because we want to make sure we're given moles, but we can't measure moles in a lab. We can only measure grams. So we're going to be doing some more molar mass conversions here. Okay, so in this problem, we're taking 11.5 grams of sodium hydroxide and dissolving it to make 1.5 liters of solution. So remember, the molarity of sodium hydroxide here is going to be the number of moles of sodium hydroxide divided by liters of solution. So this we know, right? The problem tells us you have 1.5 liters of solution, but they tell us grams of sodium hydroxide. So the first thing we need to do is figure out moles of sodium hydroxide. So if we have 11.5 grams of sodium hydroxide, we know that 1 mole of sodium hydroxide contains 40 grams. Okay, again, I just calculated that molar mass using the values on my periodic table. Okay, and we end up with 0.2875, and I'm going to leave this value. I'm not going to round it until the very end. Okay, but we get 0.2875 moles of sodium hydroxide. Okay, and so our molarity is going to be equal to moles per liter. So we're going to take that 0.2875 moles of sodium hydroxide dissolved in 1.5 liters of solution. And this is where I want to round to 3 sig figs. Okay, don't do any rounding until the very end. Okay, we're going to end up with 0.192 molar. Okay, so you can either write it as 0.192 molar, or if you wanted, you could say 0.192 moles per liter. Okay, these are both the same unit. The capital M is the more traditional way that we see it. Okay, like in some of the problems on OWL, it'll tell you you have a solution that's 0.192 molar. Okay, this is the more common way to abbreviate the unit for molarity, but just remember that molar means the same thing as moles per liter. Okay, these are two different ways to say the same thing. The capital M is the more conventional way to do things. Okay, so then we have one more problem down here, very similar. Okay, we're given 1.56 grams of hydrogen chloride. Go ahead, convert that to moles. You know that 1 mole of hydrogen chloride is going to weigh 36.46 grams. Okay, again, that's just the molar mass. So we have, I mean, you don't have to copy the whole thing, guys, but just, give me a few extra digits when you do this step. We'll do that. We have 0.042787 moles of hydrogen chloride dissolved in 26.8 milliliters of solution. Oh, that's so evil, right? Because remember, molarity is moles per liter, so you need to convert those milliliters to liters. Let's do that conversion. I didn't leave myself quite enough room, sorry. 26.8 milliliters. You know that 1 liter contains 1,000 milliliters. Okay, so we have 0.0268 liters of solution. Okay, so our molarity is going to equal moles of solute per liter of solution. Moles per liter. Sorry, bad spacing. And we end up with 1.60 molar. That is our concentration, or our molarity of this solution. Okay, so I know sometimes the OWL problem, they'll give you molarity and you have to find moles or volume. Okay, you can either plug and chug everything into this equation, or you can remember that molarity is really just, if you know the number of moles in 1 liter, you can treat this just like a conversion factor as well. Okay, so next let's look at some dilution problems. So all of these dilution problems are also in the PowerPoint slides. Okay, remember those are posted on portals and you can see them in the lecture videos on YouTube. Okay, so we kind of talked through this in the lecture, but now I want to actually go back and solve it. Okay, so remember the whole point of dilutions is that it's easier for me to buy one big bottle of 17.5 molar stock solution, okay, super concentrated stuff, and then water it down throughout the year to make the specific concentrations that I need, okay? That's way easier than buying a new bottle of a specific concentration for every different lab that I do, okay? I don't have the money to do that or the space to store all those bottles in my prep room. Okay, so a lot of times chemists will just buy a stock solution and water it down through dilutions. Okay, so remember, if you do a dilution, you're taking a tiny little bit of the stock solution and you're adding some water. Okay, so however many moles you take out of that stock solution, that's the same number of moles that's going to be present in your diluted solution. Okay, so when we're reading this question, I told you to think, well, start off by thinking, how many moles of acetic acid do I actually want to end up with? Or how many moles of acetic acid are actually going to be present in my final diluted solution? Well, I have 500 milliliters of a 1 mole per liter solution. Okay, first thing I want to do is take that milliliters, convert it to liters. Okay, so I've got 0.5 liters of solution, and I know that there's going to be 1 mole per liter. Okay, this is using that molarity as a conversion factor. Okay, so in my final diluted solution, I'm going to have half a mole of acetic acid. Okay, that's the amount of moles I want to have present in my final solution. So that means I need to take whatever volume of stock solution is necessary to give me half a mole of acetic acid. Okay, so that's what I ask you in the second problem now. This is like thinking through what we're doing. Okay, so how much of my stock solution is it going to take to give me 0.5 moles? Well, if I want 0.5 moles of solute, I know that in my stock solution, 1 liter contains 17.5 moles. So see, in both of these problems, we're using molarity as a conversion factor. Okay, and again, the moles or the liters on top or bottom is just depending on what are we looking for. Okay, so I would end up needing 0.0286 liters of stock solution. Okay, that's great. If you want to leave your answer in liters, you can, but just know that measuring out this many liters is going to be very difficult. Okay, we would probably be using a small graduated cylinder, and this is probably a more appropriate number to report in milliliters. Just make sure when you're doing OWL, you pay attention to what units it wants. I'll try to remember on tests and quizzes to specify what unit I want volume in. Okay, that's my bad on these problems. Okay, so we're going to end up taking 28.6 milliliters of our stock solution. Okay, so this is the final answer. And the reason that I did it this way is because I wanted us to think through what we're doing with dilutions. But of course, in the PowerPoint, you know that I give you a formula to help you solve it every time. Okay, and so now we're going to redo this same problem first, and then we'll do 2 more real quick. Okay, we want to take the molarity of our concentrated and the volume of our concentrated, which in this problem is the unknown. So we've got 17.5 molar for our stock solution, an unknown number of liters for our stock solution. Set that equal to the molarity of our dilute solution and the volume of our dilute solution, which we said was half a liter. Okay, if you do this algebra and you solve for x, you would get the same number. You would get that x is 0.0286 liters, which again, you know is equal to 28.6 milliliters. Okay, so the formula is just kind of condensing this whole thought process here behind what are you actually doing in a dilution. Okay, so make sure you understand this. Of course, I'm okay if you use the formula. That's why they're there. They're there to help us. Okay, but it's important that you understand what you are actually doing in a dilution process. Don't be robots who just plug and chug numbers into an equation. Okay, but we're going to plug and chug into the equations here just so we can practice using it. Okay, what volume of a 16 molar stock sulfuric acid must be used to prepare 1.5 liters of a 0.1 molar acid solution? Okay, so we have the molarity of our stock solution, the volume, which we don't know, and we're trying to prepare 0.1 molar. and we want 1.5 liters of it. Okay. If you solve the algebra, of course, you know you're going to have to take the 1.5 times the 0.1 divided by 16. Okay, and you are going to get 0.00938 liters. Again, good luck measuring that accurately in a lab. You're probably going to want to use equipment that can measure in milliliters. Okay, so this is probably better to report as 9.38 milliliters of that stock solution. Okay, so again, it's a tiny, tiny little amount of stock solution, and then we're adding enough water to get it up to 1.5 liters. That's more than half a pot bottle. Okay, this is teensy tiny because it's super concentrated and we're just watering it down. Okay, last one, very similar. Okay, we have a 12 molar stock solution. We want to know how much of it we need in volume. We're trying to prepare a 0.25 molar solution, and we want 0.75 liters of that solution. Okay, so if we do our algebra, you're going to need to take 0.25 times 0.75 divided by 12. And you get that x is going to be equal to 0.0156 liters. Again, easier to measure that in a lab in milliliters. And we would need 15.6 milliliters of our stock solution. Okay, so OWL might have you solve for different variables, but really the equation is the same. I care that you understand that however many moles you take out of your stock solution, that's how many moles, or I'm sorry, however many moles you want in your diluted solution, that's how many moles you're taking out of your stock solution. So the amount of stock you need in your dilution is going to depend on the number of moles you're shooting for. Okay?